I did it to myself. I did it to myself. Hey guys, welcome back to the frustrating Philco 48-1000 project. I have introduced this segment and recorded so much footage that I'm probably just going to toss out because none of it led anywhere. I'll briefly tell you what I've done. I attempted an alignment. I went over the tuner, replaced the CRT with a test CRT, done injection with the B&K 1077B, going through the various stages. Nothing has gotten me anywhere whatsoever. Honestly, I'm kind of on the verge of, at least for the now, putting this project to the side because I've spent way more time than I ever thought I would be on this project. There is definitely a lack of gain. I cannot figure out why. What I can tell you is that we know if we inject right at the grid the first video amp, we can get a pretty strong image out of it. But with weird, seemingly retrace lines, but I don't really think they are, and a very unstable horizontal sync. Now, when I was at the Early Television Museum a few days ago, they have a restored Philco 48-1000, and it works exactly like you would expect a TV to, with brightness and contrast and hold. It locks, it's stable, no retrace lines, or if they appear, it's only because you're driving the brightness too hard. Nothing like how this set behaves. The alignment, the coils seem to respond like they're supposed to. Nothing has stood out other than there's uniformly low gain throughout. I've gone over the AGC so many times, I'm sick to death of it. I've checked all the voltages on the tubes, I've checked continuity, I've checked resistors, checked capacitors. I can't find anything wrong with it. I've tried injecting the signal at different points from the antenna input directly into the tuner, right after the tuner with the B&K. All I can tell you with the B&K is if I go into the grid of the first IF stage, we've got 3 IF stages here, I get a faint image. If I inject it at the second or third, I don't get anything. If I do direct video injection from the B&K to the video amp, I get an image, but it's not that strong because I think it puts out a weaker signal than the VG91. I have checked with my scope, because I got a scope with 400 megahertz bandwidth. I can easily just directly look at the IF stages. Video carrier is about 26 megahertz. I can easily see the carrier, and I can look at the grid and the plate of each stage. And there is gain at each stage, 5 to 7 times, it would seem. Problem is, I don't know what it's supposed to be. Alright. In addition to posting these videos on YouTube, I've also been discussing this project on the Antique Radio Forum in the television area. And some guys over there, well, they basically talked me off the ledge. So rather than chuck this set into Lake Michigan, we're going to take another whack at it. So I discussed my issue with lack of gain and trying to do signal injection and getting frustrated because I'm not sure what the levels should be at various points. Well, put our heads together and come up with some reasonable guidelines. For example, it uses a 10 BP4 CRT, and I think they modulate the grid. So typically, you want about 40 volts peak to peak going into the CRT to get good contrast. So we've got that data point. Now, one thing that confused me about that is if you look on the service info, they do have some waveforms they show with the tubes, and here's the video output tube, and they show 8 volts peak to peak coming out of it. Well, that's not 40 volts, is it? But an astute observer mentioned on the forum that, hey, they say all readings are taken with the controls fully counterclockwise. Now the contrast control controls the gain, the video output tube. So when you're fully counterclockwise, it's minimum contrast, going to be minimum gain, so then the 8 volts starts to make more sense. Because the input to it was the first video amp, which has 10 volts peak to peak coming out of it. So that's what was so confusing, is the first video amp puts out 10 volts peak to peak. The second and final video output you would think would be more than 10 volts peak to peak, or why even have it? But the contrast control controls the gain on the output tube, but not the first stage. So it's actually, when you turn the contrast all the way down, you're actually attenuating the output a little bit. So they say. Now, we don't have waveform readings for the video IF stage 1, 2, 3 or the detector, but can come up with some reasonable guidelines by working our way backwards. So, for example, several people chimed in, around the video detector, we should have about 2 volts peak to peak, I believe. So if you got around 2 to 4 volts peak to peak around the video detector circuit, you can figure that stages before that, the signal is going to be weaker, and it seems it's reasonable to expect 5 to 10 times gain per stage. So say we've got 2 volts at the detector input, then the prior stage would be, say, 1/10 of that, so 200 millivolts. Per stage prior to that, 20 millivolts. But it's probably more likely about gain of 5, I think, rather than 10. So that's a trade-off typically with amplifiers. If you want wide bandwidth, you're going to sacrifice some gain. So rather than having a single sharp peak like in an AM radio, these are wide bandwidth, and when you spread out that frequency response, you typically lose some gain there. I'll refer back to the forum because I got reasonable voltage levels from the tuner through each stage. What I'm going to do now is feed a signal into this set, get it working as best I can, and measure those and jot them down. And they also mentioned, hey, when you probe in like I've been trying to do and stick the scope probe on the grid of the input of a video amp, the capacitance on that probe is going to affect the circuit and load it down. And I've noticed that because I do get a faint image on the CRT face, and when I probe it with the scope, the image will fade away or get distorted, so I can tell I'm loading that down that circuit too much, which means the reading I see is probably less than what's there in reality, so that's something good to be aware of. Alright, so let me get this thing warmed up and tuned in. Okay, I can see my test pattern. It's a bit jumbled, but it's there. So let's start at the output, and we play with that contrast, put it all the way down, so the image is faded away. And I'm going to take some notes, and I'm going to write down these waveform levels at the various points. Okay, now this might be kind of interesting. So, well, let me tell you what I know so far. Here is the output of the final video amp. Get this down to 1 volt per division. So with contrast maxed out, maximum gain throughout the whole thing, get a little over 4 volts peak to peak. If I do minimum contrast, about 1 volt. It's supposed to be 8 volts at that point. Okay, let's go to the video amp output. Let's see, pin 6. This should be 10 volts peak to peak. And it's about 1 volt. Okay, work my way back to the detector, the input side of the detector. And when I hooked that up, I was like, whoa, it's way off scale on the scope. So it looks like we got a really strong, healthy signal going into the detector. Let me change the scale here. It's about 15 volts peak to peak. Now, of course, that's the carrier, it's not the detected signal. But it looks like we got a pretty strong signal going into the detector. Okay, well, what's coming out of the detector? So that would be, schematic's hard to read. I think pin 7. So, yeah. So that would be our detected envelope. That's a little over 10 volts. So how do we go from the 10 volt output of the detector to less than that at the final video amp? It seems to be somewhere between the output of the video detector and the final video amp. We're losing something. So the output of the detector goes through coil and a coupling cap to the grid of the video amp, pin 1. Let's see what the grid of the video amp, pin 1, has got on it. Nothing. Or it's so low we can't see it. Now this is where, when I was doing direct injection, this is where I was injecting it to. Okay, if we get down to, it's about 200 millivolts. Somehow it went from, what was it, 10 volts peak to 200 millivolts between the output of the detector and the input to the video amp. Maybe I'm finally on to something. So, again, huge signal out of the detector, tiny signal into that. So my first thought is that coil's open. Alright, let's poke around here, see what we can find. That is the peaking coil there. Checked these earlier, and I was pretty darn sure they all had continuity. As possible. 5.4 ohms. It sure seems like it's got connectivity. Then it goes to a 0.1 cap, and it goes to the grid of that tube. And on that tube, I wonder. I did it to myself. Check this out. Alright. That is a replacement resistor on the grid of the first video amp tube. First glance, well, it's supposed to be a 1 meg resistor, and I see a brown, a green, and a black stripe. But they're not in the right order. If it was 1 meg, it would be brown, black, green. What do we have? Brown, green, black. That's a 15 ohm resistor, not a 1 mega ohm resistor. Let's put a 1 meg resistor in there and see what difference it makes. So effectively, we were nearly completely shorting out our video signal. Now, in my defense, and it's not much of one, I admit, I reached into my parts bin and pulled out a 1 meg resistor. Problem must be that when I've sometimes taken parts out and then had leftover parts and put them back in the parts bins, I put it into the wrong tray. Usually when I buy parts, I buy 10, 25, 100 of a resistor at one time, and I take them out and I dump them into the drawer. But for there to just be 1 or 2 that are the wrong value, I must have taken them out, put them back in, and anyways. Point being, I wasn't careful and I didn't double check. Now, somebody had asked to see how I've been doing these joints, because they said it looked like I was doing a neat job and they wanted to see what my technique was. So pretend this is one of the original parts. What I've been doing is I cut the lead on one end so I have something to hold on to. Then I either use pliers or my fingers, heat up the lug and unwrap it. See, these lugs don't have eyelets. The leads on the parts are just wrapped around them. Now, if the part you're taking out is under several layers of other wires, that's a little bit trickier. But generally, as I've been doing this, the parts I've been taking out have been on the outermost or near outermost layer, and I can simply heat it up and unwrap it, and the parts come off. Well, like that. I mean, yeah, sure, that was a new part I put in, but the old ones have been coming out just as easily. Now, on the flip side, I want to take out the stump that's remaining, and for that I will use pliers because there's not that much left. Now, this is a tube socket, so this is an eyelet. So, a little bit trickier to get these out. Now, the Loctile sockets, those are also terminals that are wrapped around, but these little miniature guys, they're through-hole eyelets. So but when I inserted this lead, I just put it through the hole and didn't wrap it around. So, there we go. Piece of cake. Alright, let's get a real 1 mega ohm resistor. Brown, black, green. And let's double check the value before we install it, which I do recommend. You never know, you might get a bum part too. That is 1.004 mega ohms, close enough for me. Now let's install it and solder it up. Now what I do wonder is, yes, I put a new part in there, but when did I put it in? I'm pretty sure the first time I powered this up, or towards the beginning, I just did a recap and I didn't check the resistors and I wasn't replacing them until later on when I was troubleshooting. So, why was this, or you know, when did, or was by chance did I detect that this was bad before I ever tried doing signal injection and all that stuff? I don't know. Go back and watch the footage and look at my reference photos. I was soldering it when I took the lead out. That eyelet got closed back up, so we're going to heat it up. Bend this lead a little bit and try to get the thread through the needle and lug through the eyelet, so to speak. There we go. And then I'm going to go back and solder the end that I wrapped around if I can find the solder. There it is. So yeah, there's a lot of parts in this set, but it's not difficult to work on for the most part. It was easy to get at. I'm going to go back over here to the eyelet and nicely fluid and for it to cool and clip off the excess. Touch that up a little more. Alright, so power back on. I suspect we're going to see a slight difference in performance now. I just really wish I hadn't taken that CRT out. Now I gotta remount the stupid CRT. Oh, yes. Yes. That has made a massive difference. I can see some beautiful color bars now. So let's go back. Look at the signal going into the grid of the video amp now. Hey, look at that. It's off screen on my scope. The signal is so much stronger now. What really gets me, I mean, aside from, yeah, I made the mistake. I'm glad I found the mistake and fixed it and all that. A little bit better now. Is that I believe I did a video not too long where I talked about this very topic. That I see guys on the forums and Facebook and various places online posting about problems with their sets and pulling their hair out and getting frustrated, and time again it turns out to be a mistake that they made. And I just did exactly the same thing. It's rare in my experience, because I not only my own projects, but I like to follow other people's projects and help when I can, is that it's rare that it's something exotic in the set. Like I was thinking that there might be bad ceramic caps inside the IF cans or something like that. When no, reality is that it's most likely a mistake that you made when you took a part out and put a new part in. And yes, after many years of doing this, I make mistakes too. So when I said I could see the change right away, yeah. So I'm feeding in bars, grayscale. This is with contrast all the way down. The signal's way too strong. So now I have too much gain, so I'm going to back off the input signal to the set. And there we go. Some lovely grayscale bars. I can play around with the brightness a little bit. And I've also got AGC turned up all the way. Probably back off on that a little bit too. And now for me screwing around, I'm sure the alignment is not quite as good as it could be. Hey, look at that, crosshatch. And voila, it was just that easy. Man, I was so close at giving up on this project. Glad I stuck with it. Okay, now here is some video programming. Now, a couple things. One, I'm using a 5AXP4 test CRT inside of a focus coil field, which throws off the focus on it, so we just have to ignore the fact that it's slightly blurry. But there we go. That's contrast all the way down. I can turn the contrast up. Brightness down. Brightness up. Let's see, vertical hold, bam, lock, horizontal hold, lose it, lock, lose it, locked. It's not making crazy sounds. Fantastic. Oh, actually I can get the focus even better. So, there we go. Now I get to go through the alignment again and try to do a better job. No doubt there's some interference because I just have loose leads hanging all over the place. Alright, I think we got this. Okay, now that the set is more or less working, I'm going back to finishing up some cosmetic stuff. I want to clean up these controls, deox it, lube them up, clean off this high voltage cage, button it back down. And then I want to go through and do the alignment, the proper alignment. Earlier I'd followed the Sam's PhotoFact alignment, thinking that the various flavors of this chassis were close enough, but when I went back and looked at the rider's service info for the code 125 with the early type horizontal oscillator, I saw it was slightly different. And then, of course, there's sound, which we still haven't heard. Now, you may have noticed that I left an old cap up here. That's because it's on the volume control, and we haven't bothered with sound yet. That's why I haven't replaced it yet, but that will certainly get replaced shortly. And also, reading through the alignment notes, I found a few helpful tidbits saying that you can do it without the CRT yoke being attached. Pop out the horizontal output tube, the vertical oscillator, and I think the vertical output tube and horizontal output tube, something like that. And you can run this chassis without the CRT or the speaker being connected. And I don't have to worry about high voltage or getting shocked or anything like that. So I think I will give that a go. Alright, so all that and more coming up in the next installment. Boy, I am so happy that we can move forward with this project.